Hi, class. Let's go over some array operations. What I mean by this is given an array, let's do some stuff to it. So we'll look at 5 things. The first is how to sum up an array. And we've been summing numbers for a good number of modules now, so this will be easy for us. Next thing is to do a max and a min on an array. We know the algorithm, just how does that fit in the context now of an array? Third is how to compare two arrays. It's not as simple as saying is array 1 equal array 2. We'll look at copying as the fourth thing. Copying arrays is not as simple as an assignment statement. Array 1 equals array 2. We can't do that. And then finally, we'll look at parallel arrays where we have two arrays. They're separate. They're completely separate. But corresponding elements in those arrays have a relationship. So we'll talk about that. So let's jump off here with our very first thing. We want to figure out the sum of this particular, let's do that. We want to figure out the sum of this particular array of doubles. There's 12, perhaps these are scientific measurements that have been collected from an instrument. So, to get the sum, we just have to traverse that array, start to finish, in a for loop. So that's for I equals 0 up to size 1. And then we'll just use another subtotaling or accumulator or summing variable. All three of those names work. And we'll just add the array element each time we go. So here's that code. Let's take a look at it. The first thing we do is in line 12, we create our summing variable, and this will be of type double, of course. Line 13 is our for loop, but here's the magic. Every time through, we're going to take measurement sub I, that's the array element, measurements sub I, and then just add it to sum. And at the end, we will count that sum, and here it is. We've got 683.8. So this is nothing unusual. We've seen this structure before. Now, the only difference is using our correct array reference here in order to access that element. Let's take a look at max and min next. We'll use the exact same algorithm, but in the context of an array. Remember, our challenge was, well, what do we initially set min and max to? And when we were processing a file, we would always set that to the first element. And we'll do the same thing here and set that to the first element. Okay, here in line 19, we've declared our doubles for min and max. And then in line 20, we're going to set those to the first element of the array, the 0 element. And then I'll just output these min and max just to validate that those actually went through. And sure enough, it is set min and max to 12.3, which is the first element of the array. So we're good there. Now then our next thing is, well, we'll just step through that array again. We don't have to look at the first element because that's already been analyzed. So we would just go from the second element to the end here and put it through a for loop. And then we'll use the exact same if statements where if, and here's the code, if the number in the array that we're examining, and that's always measurement sub I, if that's greater than max, we set max to that number. Now note, a few of you are still putting an else if here, and remember that that won't work. There's small edge cases where that won't work, and you'll need to just have two standalone if statements here inside this for loop. And then the other important thing to note here is that we're going to start with 1. So that means we're starting with the second array element, the first one being element number 0, the second one being element number 1. And that's because we've already, again, looked at measurement sub 0. Then let's go ahead and let's get some output in here. I will count the min and max. And let's run it. Let's see what magic has happened. There's our min and our max, 98 and 12. And let's just go up and sort of glance at our array and give it a validation here. Yeah, it looks to me like 98 is the max here, and I am also observing 12.3 is the min. So it's looking like our code is working. So no real difference from the min-max algorithm that we've used before. Just remember, how do we reference an array element? Because that's what we'll be looking at every time through the loop. And then don't forget setting min and max to that first element. Let's talk now about how do we compare arrays? And what do we mean by that? Well, how do we get this? How do we answer this question? Is array 1, is it equal to array 2? So that's a good question. And we can't just use the equality operator like we would think here. We can't just put this if into an if statement and then expect the compiler, or the processor, I should say, to adequately assess that. And this goes into some deeper kind of issues that you'll learn about in more advanced programming, but examining just whether the two data structures are alike can only happen if we examine it element by element. So to tell if two arrays are alike, we have to go through each element and compare those. Because we can compare array elements. Those are discrete, sort of like variables. But comparing an entire array, it won't let us do it. Python will, but C++ won't. So what we do instead is we just put it through a loop. And we use a Boolean. And in that loop, we compare adjacent or corresponding elements. So array 1's sub-0 and array 2's sub-0. And if they're equal, well, then we'll go on to the next element and compare those, and then the next and the next. If any of them are different, well, then we just stop the whole thing right here and say, oh, the entire the arrays are different because at least one element is different. So that's the way we'll do this. So let's get some pseudocode up here, and then we'll look at some real code. Here's our pseudocode then for seeing if two arrays are the same. First, we'll set a Boolean to true. I'll use the variable, how about the name same down here? I'll call it same if the arrays are the same. And initially set it to true. And then for each array element, so this means that we are going to step through the arrays using a for loop, and we can just do a for loop based on the size of the largest one. I think one of the first things we'd look at to compare is, well, if the size of each array is the same, then we can kind of keep going. So assuming that the sizes are the same, then we will just use a for loop. We'll compare corresponding elements. And then here's the algorithm right here. If they're different, then we're going to flip the Boolean to false. And then we're just going to get out of that for loop. So let's see how this would relate and what the variables states would be if we just try and compare these two arrays. Array 1 has the elements 1, 2, 3. Array 2 has the elements 1, 3, 3. Okay, so let's go in a for loop. We'll go in a for loop from 0 to 2. And that's inclusive. And so the first time through, we're going to see is, and let's call this one array A and this one array B. How about that? So we'll ask, okay, is A sub 0, is that equal to B sub 0? And if it is, then we just go to the next loop. So now I was 0, now I is 1. Okay, so now we look, is A sub 1 the same as B sub 1. And no, they're not. A sub 1 is 2 and B sub 1 is 3. So this if statement here is false. So what do we do if they're different? Okay, we flip the Boolean to false. So this is false now. And then we can exit the loop. And we can just do that with a break statement. Well, then now, once we're out of this loop, we have this Boolean and it's set. It's either true or false. And that means if the arrays are either the same or they're not. Now, if a set of arrays kind of survives this process and goes through without this Boolean ever flipping to false, well, then the Boolean remains true because we initialized it to true here, and it'll come out the other end remaining true. Now let's compare this pseudocode to some actual code and kind of step through that. Here's our actual code then. In line 1, we set that Boolean same to true. Line 2 is just a for loop header. We're going to go through the entire array, and that's of size SZ1, I'll say. Line 3 is just that guard in the middle of our for loop. And this is saying, well, are the corresponding elements of arrays A and B, are they the same? So our actual code is saying, all right, if A sub I is different from B sub I, meaning if it's not equal to. So if it's different, then we've got a couple of tasks here. We will set same to false, and then we will break. And what break does is it gets us out of the nearest loop. Or the loop that we're currently in hierarchically, the lowest loop that we're hierarchically in. So this break statement right here then is going to go and start hunting up and up and up and say, okay, which for loop am I in now? It's not an if. Oh, here, it's this one. So a break statement is going to stop that loop. So then we exit out of here, and we've got this variable now, same, that's storing the exact state of that array equality. It's true if they're equal, it's false if they're not equal. So that, with that pseudocode in mind, and that code, I should say, let's look at some actual code. Okay, now in this section, I've got, let me unzoom just a bit. There we go. So in this section here, I've got these 3 string arrays, and they contain names, okay? String arrays, of course, bounded by double quote marks, and all of these are of size SZ2, which is a constant up here that you see is set to 3. And then we're going to do some comparing. We're going to see if array 1 and 2 are the same, 2 and 3, 3 and 1, etc. And then we'll store Booleans for all of these, and we'll use this exact same code here. And then we'll be able to output just what the results of those comparisons will be. All right, so let me get busy coding that. I'll be back with you in a second. Here's that code then to compare these. Let me zoom a tiny bit. There we go. So remember, we cannot do this comparing explicitly using the relational operator. I'm sorry, the equality operator. Cannot do that. So instead, we step through it. So here is our Boolean. Here's our for loop stepping through. And our for loop has only one statement in it. That's why we don't need braces for the for loop, because there's only one statement in it. It's an if statement. And then here's inside that if statement. If the names are not equal, then we've got those 2 tasks. One is let's flip the Boolean, and second, let's break out of this loop. So this runs. Of course, it's not doing anything right now because we haven't told it to do anything. So let's just put in some code to print the status. What did we find out here? So here's some very simple code to output the results. So we're going to output first this string, name1 and name2 are, and then all we'll do is put the word not in if they're not the same. And then otherwise, both of these outcomes will print out the words the same. So we can print that out regardless. It's just that word not that we've got to check. And only insert that word not if the arrays are in fact different. So let's then run this and we'll see here it's saying names1 and names2 are not the same. Let's validate that. Let's go up a little bit. And yep, we see here name1 and name2, the very first element is different. Bumblebee versus Eddie Eggplant. All right, so that's name1 and 2. Let's compare, how about 1 and 3? So I'll go up here and change this to 3 and 3. So now we're checking 1 and 3, and it's saying that 1 and 3 are the same. And that does make sense because these are both the B, C, and D names, B, C, and D. So that code should help you. Again, given that Boolean with the status, we can just output whatever state that we want. Now, if you're interested in some more kind of advanced coding, check this out. Here's a count statement that does all of that just in one simple count statement. And this uses the conditional operator. So read up on the conditional operator in C++, read up on that in the book. And this is a way that you can put a conditional operator within a count statement. So what this is saying is, and then these parentheses are required if you're going to put a conditional operator within a count statement. And what this is saying is, okay, what's the state of same? Is same true or false? So if it's true, it is going to execute this expression right here between these two punctuation marks. If it's true. If it's false, it's going to execute this expression. And since we're in a count, this is going to be the argument sent to the count object for output. So the first time, if they are the same, it's going to send nothing, the empty string. If it's not the same, then it's going to send the word not. So that's a neat way to compact our code. Let's go back to sort of the normal way here that we're learning, and we see that. Okay, so that is comparing, and let's go on to copying next. Let's get on now with copying arrays. Our first step is let's go ahead and declare a second array of the same size as the first array, and it'll just be blank, empty. And then what we cannot do is say, oops, let's get a better ink pad. And we can't say array2 equals array1, where this is the old one and we're trying to just assign it into the new one. We can't do that. Python we can, but C++ we can't. So what do we do instead? Well, we will traverse the array and then just do the assignments in a for loop. And let's take a look at what that would look like. Here's our pseudocode. It would just be a for loop going from 0 to size. And we'd have exactly one statement in that for loop, just a simple assignment statement. We're going to use the assignment operator here. And whatever the first array's element is at sub I, we are going to just reassign, or not reassign, but assign it to the empty array 2 sub I. That's simple. Just step through it and copy old to new, old to new. So this is a great way to create a copy of an array for safekeeping, for analysis later, for storage and archive copy, before it may be manipulated further. So all good reasons for copying arrays. Looking at some code now, I've got this array that I want to copy, a readings array. And yeah, it's got the same values as before. Now in line 55, I create that second array. I'll just call it backup because that's going to be descriptive of the purpose for which I'll create this. I just want to create a backup copy of this array. So we'll create it the same size declarator. And then remember, what we absolutely cannot do is just this assignment statement right here, backup equals readings. Again, in Python, this is legal, but in C++, it's not. So we have to do this code instead. Here's a for loop going from 0 to size, and in it, we just copy old to new. So this is the existing array element, readings sub I, and we're going to copy that now and assign it to backup sub I, which exists, it's just uninitialized and it doesn't contain anything. As just a reminder, let me show you what happens if we do try and output an array that hasn't been initialized to any values. Let's just, as a reminder, see, well, what kind of garbage will end up coming out. So here's a really, really fast piece of code just to see what is in that val. And you can see there's a lot of garbage in that backup array right now. A bunch of very small numbers. This is 3.03 with the decimal places moved 86 positions that way. So a very, very small number. And you can see that this array contains that. And that's just because we haven't initialized it. This is just some shorthand code. This is using a range-based for loop. You can study about that in section 7.4. And it's a great way to just do a quick and easy traversal of a loop when the index is not important, as it is in this case. Otherwise, we just step through it in a for loop for int I, I equals 0, I less than size, I plus, and we will just count backup sub I, and this will generate the same output, a bunch of those very, very small numbers. So we've got to initialize this, and the way we'll do that is through this assignment. And there's the assignment right there. So let's now output backup and see if it's got the exact same number of items as readings. So I'll do the same thing here. I'm just going to do the shortcut range-based loop. And this will dump out backup. And you can see here, yeah, look at that. It's the exact same values as the original measurements right here. So I think we're doing good there. And we successfully did make a backup copy of it. So I'll remove that line there. Okay, that is copying an array. Remember, the algorithm got to step through it with the for loop and copy each individual element. Now, let's talk about parallel arrays next. Okay, let's get into parallel arrays. They are 2 or more arrays, all of the same size. And even though they are completely separate, standalone data structures, arrays, not related to each other at all, technically, we can treat them as sort of one unit because they relate to one entity. So here's a good example. Let's say we have a person, and we want to describe a few attributes about this person. And let's just start with something simple, like what's their name and what's their age. Well, right now at our level of programming, the way we would store this would be, of course, in arrays. That's how we will store things for a bit. Until later classes when you see other data structures that we can use. So we'll have one array for the name and one array for the age. One is a string array, one's an int array. So that's exactly what we have going on down here. These two arrays, and yet they're related. Let's say that Joe here in the first element of the names array, let's say his age is 26. So these two are related. They are two attributes of a single entity. In this case, these are two demographic attributes of a person named Joe. So then similarly, let's say Julie is here and Jeff is here. Then these relate to each other that way. Or in code, we could then say that age sub 1, let's say, is going to be related to names sub 1. Or if we put this in some kind of a loop and do a for, we can make this I for the index, and that will output then, the index, and you can then put related pairs in there. So this is how parallel arrays work. Let's take a look at code and see this in action. Here's a couple of arrays. One is that ages array. It's an integer. There's an initialization sequence there. You'll note that I did not have to put in a size declarator right there. And why is that? Well, it's because the processor is smart enough to figure out that we gave it 3 initialization values. So it's going to create an array of size 3. Then below it is the names array, and we're going to have these relate to each other. Hannah Hummingbird is 22, Iggy Iceberg 26, Jerry Jellybean is 24. So let's just crank out a for loop right now that's going to output these pairs of data. Okay, we've got a simple for loop here, just going from 0 to size. And then here in our count statement, note that we are outputting from 2 different arrays, the names array and the ages array. These are the parallel arrays, but we're going to output the same element, the ith element, out of both of these arrays. So that's how we get the relationship visually displayed. Let me run it, and you can see here are the names and their associated ages. Pretty straightforward. Now we could dress up our output just a little bit. Maybe instead of separating it by a space, let's put their age actually in parentheses. So we'll do this. We will put a parenthesis immediately before the ages output and then immediately after. So now we'll see the same thing, and just the ages of each person is listed in parentheses. Okay, so this is parallel arrays, and this module's lab really leverages from the start this idea of parallel arrays. So make sure that you understand those and that you read that section in the book. Okay, our next video is going to take this exact code that we've done here and do functions of them. So make sure to watch the follow-on video next. All right, good luck, everybody.